eGLE e-learning development environment has been created during the geospatial project funded by European Space Agency. eGLE's objectives are to offer to the teachers the ability to easily create lessons for different topics, to support non-technical users in understanding and developing workflows to be ported onto the grid, to provide a set of services and tools supporting web services connection, specialized APIs integration and easy workflows instantiation and execution over the grid to allow both trainers and trainees to easily connect and retrieve data from distributed data sources without advanced technical knowledge. eGLE architecture has two main components. The platform built on a client-server architecture that provides basic functionalities for users and resources management as well as for tools integration and lesson generation processes. Second component is composed by all the distributed data sources, web, grid or dedicated services that can be accessed through the tools integrated into the platform, providing the teachers with the capabilities of a distributed architecture. The visual structure of the learning resource has three main structure levels. Templates hold general formatting information and divide their content in a logical structure. Patterns represent the logical organizers of one row into the lesson, grouping one or more tools side by side. Tools are atomic elements, specialized on a certain data source and interaction technique. For example, accessing OGC services, calling specialized APIs, presenting images, text or videos. Each tool must implement the specific interface required for data binding and also the mechanism that will allow the trainer to control its behavior and display settings. eGLE LCMS provides all the necessary functionality for lessons creation management and control of access. Lessons are organized in courses and can be accessed only by previously accepted students. At the top level, each lesson created in eGLE has its content organized in one or more pages, thus providing a better information management schema. On the next level, each page can hold an indefinite number of patterns. In order to improve efficiency, the trainers have the possibility to add already existing patterns, either created previously by themselves or shared by other trainers of the platform. By using patterns as logical information organizers, the percent of reused resources will increase significantly, as it is more likely to have smaller identical layout areas than entire identical pages, either in the same or in different learning resources. When creating a new pattern, the trainer has the possibility to select desired tools from the available ones and add them through drag-and-drop interaction. Any combination of tools is allowed, but they will share the same total space in width and will have the same height. Each tool and each pattern can be reused in the same page or learning resource as many times as it is necessary. Each new addition will be completely independent of previous or later usages, having independent data, interaction and display settings. According to the interaction level allowed by the trainer for the trainees, the lesson scenarios can be classified as static, when the trainees may only consult the data presented into the lesson. They cannot modify the information displayed or create new data by modifying the input parameters. Interoperability is a great challenge in the EnviroGrid's system development. Such a technology can significantly reduce problems associated with archiving, manipulating, analyzing, and utilizing large volumes of geospatial data at distributed locations. The BSCOS portal aims to support a virtual training center which has as generic users the teacher and the student. The teacher is the earth science specialist who authors teaching materials and coordinates the training sessions. The teaching materials are organized as lessons stored in the teaching material repositories. The student is the trainee who accesses the lessons in order to get presentations, to experiment algorithms on spatial data, to process satellite images, and to visualize reports already prepared by the specialists, using for example BASHIT capabilities. The themes and subject of lessons are from Earth Science domain related with the EnviroGrids project. A possible user scenario could be: a calibration process or a scenario has been executed using BASHIT. The information used for creating the model or the scenario is stored in URM and is available through OGC web services. A hydrology teacher intends to use this model as a didactical example for his trainees, so he will create a new teaching resource. Using eGLE, the trainer will have the possibility to include in his lesson tools for accessing and displaying data retrieved directly from BASHIT API and OGC web services. At runtime, the trainees will be able to visualize all the information, regardless of its source, in a unitary and coherent way inside the same resource. All the data transfer will be handled automatically by the eGLE application. At runtime, each tool is launched in an asynchronous running mode, accessing in an independent way distributed data from OGC web services, grid processing capabilities, functionalities from BASHIT API and other data sources. The data transfer is accomplished directly between the trainee's computer and the corresponding services, without passing through to the core server platform. In this manner, the eGLE application can provide better and more responsive connections to a large number of users. The interactions available to the users at runtime depend on the rules established by the trainer at the authoring time. If allowed by the security settings, the trainees have the ability to interact directly with the data, requesting computations, personalizing reports and so on.